Hey folks! Welcome to Channel 73. In the last video, we explored the key features of Python and its common applications. In this video, let us have a look at the data types in Python. But, before that, let us look at a simple Hello World program. All you need is the print statement. No fancy imports, no header files, nothing. Just a simple print statement. As simple as that. If you are a beginner, you can use Google Colab for practicing Python. It is plug and play and can be found on the right-click menu on your Google Drive. Just connect to a runtime, and you are good to go. Python has a simple and short list of data types. These are very flexible and versatile. Also, there is no need to declare variables. We can just assign values to a variable. For example, in some programming languages, there are data types like short, int, and long, which are used to hold numerical values, but having different range limits. But, in Python, there is just one data type, called int, which can hold arbitrarily large whole numbers. There are three numerical data types in Python: int, float, and complex. Int is used for whole numbers. Float is used for decimal or floating point values. Complex is used for complex numbers, having a real and an imaginary part. The imaginary part is denoted by the letter J. Python has just one text data type, string. Strings can be initialized using either single quotes or double quotes. Strings are immutable. Single quotes can be used inside double quotes, and vice versa. Sometimes, if the need arises, the quotes can be escaped using a backslash. In addition to atomic data types, Python has sequence data types as well. These are also called iterables. List, tuple, range, set, frozen set are some of the iterables. A list is a collection of items of any data type. The elements are enclosed within square brackets. Since they can contain elements of different data types, they are very different from arrays. Arrays can hold elements of the same data type. Lists are mutable. Elements can be added, removed, updated after the initialization of a list. Tuples are very similar to lists, but differ in one main aspect. Tuples are immutable. Elements cannot be updated after the initialization of a tuple. Range is an iterator data type. It can be used to hold a sequence of numbers. It takes three arguments: start, stop, and step. In this case, range of 0, 5, 1 yields whole numbers from 0 to 4 at a step size of 1. 5, the upper bound, is excluded. Lists are initialized by enclosing the elements in square brackets. Tuples have parentheses, and sets have braces. Sets are a mutable collection of unique items. The elements can be of any data type, but they have to be immutable. For example, a tuple can be an element of a set. But, a list cannot be an element of a set. Elements can be added or dropped from a set. It is worth noting that lists, tuples, and range data types are ordered, while a set is unordered. That is why we cannot update an element of a set. Sets and frozen sets differ in the same way. A list differs from a tuple. They are virtually the same, except that frozen sets are immutable. Dictionaries are an unordered collection of key-value pairs. They are an implementation of hash tables. So, the complexity of lookup is of the order of 1. In other words, the time taken to find the corresponding value of a key is the same for all keys in the dictionary. Dictionaries are mutable as well. Values of a key can be updated, new key-value pairs can be inserted, existing key-value pairs can be dropped, and so on. Boolean variables are used to hold one of the following two values, true or false. In Python, all empty iterables evaluate to false, like empty lists, empty tuples, etc. In the case of atomic data types, zeros and empty strings are considered to be false. In continuation, all non-empty values are considered to be true. Binary data types are used to handle data in the form of zeros and ones, and it is often used when working with files, network protocols, and other low-level operations. Bytes data type can store raw data in binary format. It is immutable. To convert a string into binary data type, the encoding must be specified. Note the prefix B to the string, hello. Byte array data type is a mutable version of the bytes data type. In this example, we have given as key values of the alphabets A, B, C, and D as a list. Memory view data type is a built-in object that exposes an array's memory buffer. It allows you to access and manipulate the underlying data of an object without creating a copy. There is also a null data type. It is referred to as none type in Python. The keyword none can be assigned to a variable for it to be treated as none type. Here is a summary of the most commonly used data types in Python. Now that we have a good idea of the data types, let us look at the input and output operations. Python has a built-in function called input that can be used to get user input. It displays a text input field along with the description provided as an argument to it. In this case, the description is, enter your name. When the user types the name and hits enter key, the input is received. The print statement gets this information and displays a greeting to the output console. It should be noted that the input function always takes the input as a string. In this case, the user_input variable is supposed to have a text value. So, it is fine. But, what if we need to get numerical values? That is where type conversion comes in. We can do type conversion between supported pairs of data types. For example, int can be converted into string. But string can be converted into int only when the string is composed entirely of numerical values. If there is even a single non-numerical character, an error would be raised. We can assign the converted value to the same variable because Python is dynamically typed. Python has another cool feature called fstrings. Let us look at this example. Instead of the normal way of concatenating multiple strings, we can use the variables, which are to be printed as placeholders within a single f string. We just need to prefix the string with a lowercase f and enclose the variables with braces. F-strings are a very concise and Pythonic way to write output statements if they involve variables. Slicing is a way of accessing a subsection of a sequence, such as a list, string, tuple, by specifying a start, stop, and step. It is a concise way to retrieve parts of a sequence without modifying the original sequence. In Python, index position starts from 0. We can also slice an iterable using negative indices. For example, -1 means the last element. -2 refers to the element before the last one. In slicing, the upper bound is excluded. Not specifying an upper bound would result in a slice from the lower bound to the end of the iterable. In summary, we have looked at data types and their properties, type conversion, f-strings, and slicing. In the next video, let us look at branching and looping. Until next time, happy learning!
Thank you.